Okay, so first of all, for the next question, is a question that asks you to find the corresponding displacement time graph given the velocity time graph. So this is something that I've not taught you how to do, but it's not impossible to solve. So what you need to know is that displacement time graph, the gradient will give you the velocity, right? So that means if we look at this velocity and we know what is this velocity doing, we can actually infer the motion of the displacement time graph. So in the first part of the velocity time graph, the velocity is increasing. Alright, and so if this is increasing velocity, how does increasing velocity look like here? Right, let's just use a diagram to draw the increasing velocity time graph in a displacement time graph, right? So increasing velocity is actually something like that. Am I right? It's a curve going upwards, right? So this first region refers to this kind of curve going upwards, while the second region is a constant velocity. All right. So a constant velocity graph will be a straight line going up, and lastly, this is a decreasing velocity will be a will be a curve going all the way until it's horizontal where the velocity is 0. So you're going to get a curve, straight line, and a curve. So the answer will have to be D. Alright, D. So the next question that we're going to do is on 2-6. Alright, this question is not difficult. You just have to know that the only information given is the total distance and also the total time. The total time is found by looking at the time taken for this number of intervals, which is actually 4 intervals. Alright, so if you look at the questions, it says that there's 2 drops per second, and this drop actually refers to the intervals. So 2 intervals, right, is 1 second. So since there are 4 intervals in this case, it will be 2 seconds. So what is happening is that if you have the total distance and the total time, the only formula that you can use is actually average speed, which is equal to 20 over 2, which gives you 10 meter per second. So the answer is A. Alright. So the next question that I'm going to do is 3-7. 3-7 is not a difficult question. It's just want you to find out whether the car will crash into a truck. So what happened is that the car observes the truck and there is a reaction time before it starts to brake. So this motion actually captures the whole motion of the car, where this region which has a constant speed is the time where the car has where it is the reaction time of the car. Alright, sorry you can't see, is where the reaction time of the car, while this region is actually the braking time. Okay, so in order to find whether the car is able to stop in time, we have to take the area under the graph of the whole region, because the area under the graph will be the total distance covered by the car before it comes to a stop. Alright, so if you calculate this region, it will give you 30 meters, so the car actually avoided the truck. The second part of the question is also quite straightforward. It's just asking you how long did the car driver step on the brakes. So it's going to be the duration of the braking time, which is from here 0.5 to 2.5, which gives you 2 seconds. All right.